All right. So today we're going to do partial fraction decomposition. Which you're just getting an intro to. So you're getting exposure to this, and then when you go to calculus, you'll use it. Yep, you'll apply it there. So we're going to call it PFD, because it's a lot to write, partial fraction decomposition. Come on. Okay. So PFD is the process of breaking a rational expression that is simplified into the sum or difference of smaller fractions. You have to be really, really comfortable with fractions, okay? If you're not, then I'm being honest. Either go to Math Lab, come after school, go on Khan Academy, and take like another crash course, all right? Because this is all fraction work. Okay, so what we're going to do is we're just going to think about common denominators for a few minutes. So consider this. If you have these two pieces, let's say we have 3 over x plus 1 over x minus 3. Then our common denominator, which we're just going to label as CD, is what? What's your common denominator? Good. X times x minus 3. Everybody agrees with that, right? Easy one. Okay. What if you have 3 over x squared plus 5 over x squared? Then what's your common denominator? It should be pretty obvious. Yeah, x squared, right? What if you had, let's say, 1 over x plus 2 over x squared? So it's still only x squared, right? X cubed would just be too big. It doesn't need to get that big, right? So you could just multiply this piece by x, giving you an x squared. Okay? So notice that B and C have the same common denominator even though their pieces were different. Okay? Now we're going to reverse it. So let's say this time that our common denominator was equal to x times x plus 1. Then what were our two original denominators? So if you had to break them up, wouldn't it be x and x plus 1? I'm going to give you a second to catch up because I want you to think about it more than write it. What if our common denominator was x minus 2 times x plus 3? What would our two pieces be?
X minus 2.
Yep, x minus 2, x plus 3. Okay? Now, what if our common denominator was x cubed? And this time, we had 3 pieces. So x cubed would have to be one of them, x and x squared. So now there are other combinations that we could have had, right? Like we could have had an x, and an x cubed, okay? But we could potentially have all 3 of these, right? Kind of in this descending order pattern. Okay, so I want you to kind of think about this because as we go into partial fractions, you have to think about how does this denominator break down? Like what are the potential pieces that this would have? Okay? So you ready to try an example? All right, we're going right into this. So, example 1, we have 2 over x squared minus 3x. Okay, we're going to write some steps out too on the side, so as we go through this, we'll do that. But looking at this, this is a rational expression, and it is in simplified form. What we're going to do, what partial fraction decomposition does, is it takes this already simplified form, and it breaks it down to its original problem. So we put it back to the smaller pieces, the smaller fractions that add or subtracted. Yeah.
Why would you want to do that?
So in calculus, you're going to use this. Okay, so they need it. All right. So now we have to think about what are the two denominators that we would have potentially had from this. Before you think about that, though, you should factor. If you can factor, you should. So this factors agree to x times x minus 3. Okay, so that kind of helps us to see those pieces a little bit easier when it's in factored form. Okay, so do you agree that this would break into two pieces? Okay, one being x and one being x minus 3. Anytime you have linear factors in the denominator, so x and x minus 3 are linear, you're going to have just a single variable in the numerator. So you have a and b. And if we had a third term, then we would have c. A fourth term, then we would have d. You just go down the alphabet. Okay? All right, so let's kind of start writing out some steps. So here are the steps. Step 1 is you split the common denominator into smaller fractions. Okay? Now the whole goal here is to figure out what a and b are. We're trying to break it down to its original smaller fractions that we had before we added or subtracted them together, okay, to get this simplified version. So now, how would I be able to solve for a and b? What would I want to do here? Yeah, we want to, well, not necessarily get a common denominator, but we want to clear the fraction, right? You guys don't like fractions? Let's get rid of them. How do you get rid of them? You clear the denominator. Can't you multiply through by the LCD? Right? Can't we multiply through by that common denominator and cancel all of those? So that's what we want to do next. We want to clear the fractions by multiplying by the LCD, or the common denominator. Okay? So now what we're going to do is we're going to take this piece, this 2 times, or over x times x minus 3, which is equal to a over x plus b over x minus 3, and I want to clear the fractions. So to do that, I just multiply everything by this x times x minus 3. So I'm going to go through and each piece gets multiplied by that term. So here, this 2, when I multiply that factor, doesn't everything cancel, leaving me with just the 2? When I multiply it by this a term, what am I left with? A times x minus 3. And when I multiply it by the b term, I'm left with bx. Okay? So far, so good? Okay, step 3. We're going to choose values for x that minimize the variables. Okay, so now when you do that, you're going to look at this simplified version here, this cleared fraction version, and you're going to think about what value for x could I plug in so that I could get rid of either this a or the b. So what is a value I can plug in for x to do that? 0. So I'm going to let x equal 0. And now everywhere I see an x, I'm going to put 0. So I have 2 equals a times 0 minus 3 plus b times 0. I know that a lot of this you can do in your head, but I want you to make sure that you show me this step, okay? Because these require a lot of work. And in order for me to give you partial credit, I need to see what your thinking was, okay? So I need you to show me this. So now we get 2 equals negative 3a, and our b goes away. So doesn't that mean that a equals negative 2/3? Okay, so now we know A. Let's try to find B now. So is there something I can plug in for X that will cancel A? Positive 3. If I plug in a 3, then A will go away. So I have 2 equals A times 3 minus 3 plus B times 3. So this gives me 2 equals 3B, so B equals 2/3. Okay, now step 4, once we've solved for all of the variables, once we know A and B, then we just want to plug in our solutions. Okay, so we go back to this original piece here, where we said that A over X plus B over X minus 3 is going to equal this. So I know A, it's negative 2/3, and that's over X, plus B, which is 2/3 over X minus 3. Do you think I would ever let you write your answer like this?
Nope.
Absolutely not, right? This is a compound fraction. We would never, ever do this. So we need to think about how do we write it correctly. So looking at just this piece here, do you agree that you could split it? So negative 2/3 times 1 over X is the same thing as this, if I broke it down into its two pieces, isn't it? Mm-hmm. Well then, when you multiply fractions, don't you just multiply straight across? So doesn't this equal negative 2 over 3x? And that is what this is equal to in its simplified version. Same idea here. If I split this into its two pieces, I would have 2/3 times 1 over x minus 3. So what I really have here is 2 over 3 times the quantity, x minus 3. This is equal to what we started with. And this is partial fraction decomposition. You took your simplified rational expression and you changed it back into its original form, into these two smaller pieces. It is literally just putting the denominator in the denominator, yes. Because of this, yeah. How are we doing? It seems like a lot, right? It seems kind of like, wow, what just happened? But once we kind of go through another example, I think you'll see that it's pretty easy. Yeah, Brett.
Did you get the x equals 0, x equals 3?
Okay, so I just picked those values. So I want to choose values that are going to make x go away, make it 0, so that way when I multiply it by that a term or the b term, that variable cancels and I can solve. So I'm minimizing the variables there. Okay? Dirk, did you have a question?
Yeah, can you show me like that final step again?
This one right here?
Like the,
Or this here?
like the really last, like,
This here.
yeah, like where did you put the x squared minus 3?
This here was my original problem. So this is what this is all equal to, right? This is what I broke it down to. When I solved for a and b, I just plugged them in, which is this, and that's equal to your original. If you just give me this part right here, that's a fine answer, okay? But this will equal this once we get a common denominator and simplify.
Oh, okay.
And that, right, and that's a great way to check your work, isn't it? To see if this was right, couldn't you just see if you can get the answer that they wanted you to get, right? You just get that common denominator, simplify, and it should simplify right into that. Pretty cool. Having fun yet?
No.
How would you like access to do that? Like, would you just say, like,
Yeah, use partial fraction decomposition to break this down into its original factors. Yeah.
Could you, like, multiply it by a common factor? Yeah, to get the answer.
Yeah. So if I wanted to get a common denominator here,
Yeah.
you're saying, yeah, you would just get a common denominator.
Right.
So we'd have to multiply this one by like a x times x minus or x minus 3. This one by an x.
Yeah.
Yep. And then we would have it. Okay. Ready to try another one? Okay. So now hopefully it'll be like a little bit easier because it's going to flow better. So here we have 2x minus 3 over x minus 1 squared. All right, now we're going to break this down again into the original pieces that we could have. And this is like, when you break this down, this is like the worst case scenario. This is the maximum number of pieces that you could have. So I'm going to give you a hint. There are two pieces that we're going to have here. What are they? X minus 1 and x minus 1 squared. Right, it can't be x minus 1 and x minus 1, otherwise this would be an x minus 1. It can't be x minus 1 squared and x minus 1 squared, otherwise we would have nothing to do. If this were an x minus 1 cubed, then you would have to have x minus 1, x minus 1 squared, and x minus 1 cubed. If this were an x minus 1 to the 4th, you would have to have an x minus 1 to the 1st, to the 2nd, to the 3rd, to the 4th. So you have to have the maximum pieces, okay? So you really just go in ascending order, term by term. Yes?
So it's based on how many x's you have?
Um,
What x is to the power?
yes. Is how many pieces you'll have?
Yeah.
Yeah. So now these are both linear factors, so this is an A and this is a B. If we had a third piece, again, it would be a C and so on all down the line. Okay, so what's the first thing we do? Go back to your steps if you're not sure. Clear that fraction. What am I going to multiply by? X minus 1 squared. So you're going to distribute to each one of the terms. The first term over here on the left, we should just have a 2x minus 3 left over. What do you have here with the A term? Yep, A times x minus 1. And then your B term? Just B. Okay, so now we're trying to decide, are there values of x we can plug in to cancel some of these variables? So if we plug in a positive 1, I get 2 times 1 minus 3 equals A times 1 minus 1 plus B. That means that my A term's going to cancel and I'll be left with negative 1 equals B.
Why'd you put it on those?
It doesn't matter. It's the same thing as if I wrote B equals negative 1.
No, not that. Not that. That's all I'm asking.
Oh.
I'm asking in the equation. Like in the 2x minus 3.
Why did I put what on the other side?
Let's put the 1.
Because I want the A to cancel. Anywhere you see an X, you have to put in 1. Well, anywhere you see an X, you have to plug in 1. So there's an X here, you got to put 1 in here. You can't leave it as X. Okay. So now, is there another value you can plug in for X to make B cancel? No, right? There's not. So now then, I need a different method. I need a different thing I can try. So yeah, don't you know that B is negative 1? Can't you just plug in negative 1 for B then? Because you know it. So now we have 2x minus 3 equals A times x minus 1 minus 1. Okay, so how am I going to solve for A? You don't have to distribute. Set x equal to 0. Does it have to be 0? No. Couldn't it be 5 or 100 or 3 million? Right? Like you could plug anything in for x because it minimizes your variable, right? Pick any value that you want for x and all you have left is A, which is what we want. So I'm going to choose 0 because it's the easiest number to work with. Alright, so this is going to leave me with negative 3 equals negative A minus 1. Add the 1 and divide by a negative, and you should get that A equals 2. Now the only thing left we have to do is just plug it back in. So I have 2 over x minus 1 minus 1 over x minus 1 squared. Notice I do not write plus a negative. If you write that, you're getting marked down. And that's my answer. It's fun. It's easy, right? That was the easy one. Okay? But notice we used a different method than what we used before, because before we could cancel both of the variables. Here we had to use one variable to solve for the next. Okay? Next one. We have 3 plus x over x squared times x minus 2. Okay, you're going to start trying this one on your own. So what I want you to do is I want you to set it up and then stop. So I just want you to set it up. See what pieces you would have. How would you break it down? I'm going to give you a hint. There are 3 pieces. Do you have a over x plus b over x squared plus c over x minus 2? Okay, now let me tell you this. If you would have had a over x minus 2 plus b over x plus c over x squared, you will get the same answer. So our pieces don't have to go in order. You just have to have all 3 pieces. Does that make sense?
Yes.
Okay, now what's the next thing you do? Multiply by the common denominator to clear the fraction. Please do that now. I want you to just do that step and then stop, and we'll see if we all get the same answer. So did you multiply by x squared times x minus 2? And you should get 3 plus x equals a x times x minus 2 plus b times x minus 2 plus c times x squared. Do you have that?
Yes.
Okay, good. So you have the first 2 steps down. Now I want you to start trying to minimize your variables. So I want you to try to choose values for x that help you to find a, b, or c. Okay? Okay, what'd you choose? 2? Okay, so if I choose a 2, then I get 3 plus 2 equals, I'm just going to kind of save some time and plug in the 2 in my head. So if I plug in the 2 here, this cancels. If I plug in the 2 here, this cancels. And I get c times 2 squared. So 5 equals 4c, so therefore c equals 5/4. Everybody get 5/4 for c? Okay, what did you choose next? 0. So when I do that, I have 3 plus 0 equals, the a cancels, the c cancels, and I have b times 0 minus 2. So 3 equals negative 2b, so therefore b equals negative 3 halves. Now, what did you do to find a? So you have to plug b and c in, and then you also have to choose some random value for x, right? Did you guys choose 1? Yeah, okay. So I'm going to start here by plugging in my b and c. So I have 3 plus x equals ax times x minus 2 minus 3 over 2 times x minus 2 plus 5 over 4x squared. And then we chose a 1. So if I plug in a 1 here, I get 4 equals, let's see, this is going to give me 1 times negative 1, so negative a. Here, if I plug in a 1, I get a positive 3 halves. And here, I plug in a 1 and I get a positive 5/4. So this simplifies to 3 halves is like 6/4, so plus 11/4. 4 is 16 over 4. If I subtract the 11 over 4, I get 5 over 4 equals negative a. So therefore, a equals negative 5/4. Did you get all that? Okay, so now we got to plug it in, right? And all of these denominators just go into the denominator. Okay? So my a is a negative 5 over 4x minus 3 over 2x squared plus 5 over 4 times the quantity x minus 2. How are you doing with the process? Dirk?
Like you said, when you're trying to find the last variable, like when you were trying to find a,
Uh-huh.
it doesn't matter what you plug in.
No. So I could have plugged in 5 or negative 6. It doesn't matter. I'm just trying to minimize the variable. Plug in a number that's easiest to work with. Yeah.
How did you get those denominators?
So remember these denominators, the 4, the 2, and the 4, I can't write it at the top. Otherwise it's a compound fraction. So I just move them down to the bottom. So these were my pieces originally,
Okay.
and I just put those down there with those.
Okay.
Okay? Okay, now, I'm going to show you an alternative method to solving for A, B, and C. Okay? Because sometimes this doesn't work. Sometimes there are not values that you can plug in and cancel these things out. And it's because you get more and more variables. So, I want you to do another method to practice with. So we're going to go back to this step. Once we cleared the denominator, we got this. Okay, this method is called the coefficient matchup. We'll call it method. Okay, it's super fancy name. All right, so this coefficient matchup. So here's what I'm going to do. Sometimes I'll use this even from the beginning, and you can use this method in every single problem that we've already done. Okay, sometimes it just takes a little bit longer. What you're going to do is you're going to expand this. So we're going to distribute the ax, the b. Okay, so when I do that, and I'm just going to reorder this. So I get x plus 3 equals ax squared minus 2ax plus bx minus 2b plus cx squared. So all I've done is distribute that. Now, here's what I noticed. I have this x squared has 2 terms. So I'm just going to group them together. And here I notice that these two are x terms, and I'm just going to group them together. So now I have x plus 3 equals ax squared plus cx squared minus 2ax plus bx minus 2b. These two here, these x squared terms, I could factor the x squared out and have a plus c times x squared. Here, these x terms, I could factor out the x and have negative 2a plus b. And then this constant is just standing alone. Now I want to match that up to what's going on over here. So originally I had x plus 3. I know that's like having 1x plus 3. What I don't have is this x squared term. Can I just write 0x squared plus this? And I haven't changed it at all, right? 0x squared is 0. It's just like a placeholder. Agree? Okay, so now this is the matchup part. Okay, so this 0x squared and this a plus c x squared go together. That means that 0 has to equal a plus c. This x term and this x term have to go together, which means their coefficients have to be equal. So 1 has to equal negative 2a plus b. Finally, the constants have to go together, which means those have to be equal, and 3 is going to equal negative 2b. Once you've matched these up, then you can start solving. So this is the easiest piece to start with, right? And that means that b is equal to a negative 3 over 2. So now that you know b, can't you come over here and plug it in? So I'm going to take this b and I'm going to plug it into this. So now I'm going to have 1 equals negative 2a minus 3 over 2. I'm going to solve, so I add 3 over 2, I get 5 over 2 equals negative 2a. I can multiply by the reciprocal of a negative half, giving me negative 5 over 4 equals a. Now that I know a, I can plug it in here, and I can solve for c. So now I have 0 equals negative 5 over 4 plus c. Add over the 5 over 4, and I get c equals 5/4.
That's so much easier.
So sometimes this is easier, okay? You could have done that for every single problem so far. You can use this method every time. Sometimes this method just takes a little bit longer, okay? But some people really like it, and sometimes it's necessary. So this is day 1 of partial fractions.
So you can use that all.
You can use it every.
From like 5.
Yes, absolutely. Okay?